Hello everyone, welcome! Another Tuesday, another time. It's a time again for working on Nano. Hello. Hello everyone, hello Undefnal. Oh, I'm not connected to the chat. I see. Now I am. Hey Wenderson! Nano is the light and good evening LFLF. How are you guys? How was your week? So let's just add you all to the spinner wheel. And LFLF and Wenderson. How was your week, guys? I couldn't join the dev meeting today, unfortunately. I had a private... yeah, I couldn't. Hello, Sergio! Couldn't join, unfortunately, and I haven't listened to it yet. So was there anything out of the ordinary? I don't think so, but I think, yeah, I'm going to listen to it tomorrow. So Wenderson and Sergio. Sergio. All right, and Pies is back again. Hello, guys. All right. Yeah, I was really busy with refactoring last week, and I want to show you guys what I did. So I put in a lot of hours in the message refactoring that we started in the last stream, and I finished it, and I even did more. So yeah, so where do we start? Yeah, first let's start the Bitcoin timer. The Bitcoin minutes. In 10 minutes we start with the first giveaway. All right. Yeah, so let's go to here and all right. Yeah, so in the last stream we started with refactoring how the messages were created, and this here is the sketch from last stream, and so what did we do? So we started. I don't even remember. Did we start even with this refactoring of the message? So I complained about the way the message deserialize and serialize was a bit confusing. Yeah, so all right, this one here. This here was the status quo back then, last week. And I complained that serialize and deserialize in the message trade, which is the interface for all messages that can be sent and received from nodes, that they don't match up really, because serialize would serialize the header and deserialize would only deserialize the payload. And it was as well that escalator looks wild. Yeah. So yeah, that just accumulated over the last streams, I think. So yeah, so I complained about that, so that there was a mismatch, and then I said I would love to refactor the message so that it would first it would be an enum instead of a trait, and that has the advantage that we can stack allocate the message instead of heap allocate, and stack allocation is just a lot faster. Than heap allocation. So we started this journey last week, and then I went crazy. I went wild on this. And now it doesn't look anything at it like that at all. So let's just draw how it looks now. So my plan was for the messages to look like this here, so that we have a message struct and it has a payload enum and a message header. But while I worked on it, I realized that we can even simplify this even more. And now the only thing we have is a message enum. Oh, why can't I type? Yeah, it is a message enum with all the variants in it, and those variants are just data structures, just simple data structures. And I realized that the header is actually only required for sending the data over the wire, because the header contains information about how big the payload is and stuff like that. But all of the places in the Nano node that send or receive the messages, they don't really care, really. They just want to work with the message data directly. And the fact that we have a header is an implementation detail. And I realized that it would be a good idea to hide this, because that would make all of the code that worked with messages a little bit simpler, because I would not need to know about headers. So what I did is I created this enum message, and it would have just simple data structures inside. For example, the, I don't know, confirm request payload, or the publish, like that. And these were just simple data structures. And then when we serialize the message and send it over the network, I created a new struct, and I called it message serializer. And the message serializer would just take the message, and it would create the message header internally, and no one would even notice this. Oops, that was too much. So this class struct would create the message header, and it would return just a byte buffer or a byte slice, like that. It would return the byte slice of the whole serialized message, that is the header and the payload in one byte slice. And the cool thing is that this byte slice is from an internal buffer of the message serializer